Welcome to Session 7. Today, a brand new curve joins the course, the circle. And I want you to notice something immediately. A circle's equation has x squared and y squared in it. Both variables, squared. So a line paired with a circle is a nonlinear system. And every single technique you already own still applies. Substitute, collapse to a quadratic, check the discriminant. Nothing new. What is new is the geometry, the vocabulary of secant, tangent, and external, and one gorgeous shortcut that can answer some questions without any algebra at all. First, the equation. The circle centered at the point h, k with radius r is x minus h squared plus y minus k squared equals r squared. Read that carefully, because the SAT hides information in it. The center is h and k, with the opposite signs of what you see written. If the equation says x minus 3, the center's x-coordinate is positive 3. If it says x plus 2, rewrite that as x minus negative 2, so the coordinate is negative 2. And the right side is r squared, not r. If it says 25, the radius is 5, not 25. Two sign traps and a square root trap all in one line. The simplest case is a circle centered at the origin. X squared plus y squared equals r squared. That's the one you'll see most often. Let's start with the easiest and most common case, a horizontal line. Take the circle x squared plus y squared equals 25, and the line y equals 4. Just substitute. X squared plus 16 equals 25, so x squared equals 9, and x equals plus or minus 3. Two intersections at negative 3, 4, and 3, 4. Now look at those numbers, 3, 4, 5. That's a Pythagorean triple. And that is not an accident. The radius is the hypotenuse, and the x and y coordinates are the legs. The SAT builds these problems from triples on purpose, so the arithmetic stays clean. Learn to recognize them. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. The moment you see radius 13 and a line at y equals 12, you should already be thinking 5 before you write anything down. And of course, plus or minus. Now, a slanted line, where we need real substitution. The circle is x squared plus y squared equals 25, and the line is y equals x plus 1. Substitute the whole expression, in parentheses, x squared plus x plus 1 squared equals 25. Expand that square. X plus 1 squared is x squared plus 2x plus 1. So we have x squared plus 2x plus 1 equals 25. Combine. 2x squared plus 2x minus 24 equals 0. Every term is even, so divide by 2. X squared plus x minus 12 equals 0. That factors as x plus 4 times x minus 3. So x equals negative 4 or x equals 3. Back substitute into the line the easy equation. When x is negative 4, y is negative 3. When x is 3, y is 4. The 2 points are negative 4, negative 3, and 3, 4. And notice both points sit on that same 3, 4, 5 circle. Let's stop on the trap, because in circle problems it is absolutely lethal. When you substitute y equals x plus 1 into y squared, you get the quantity x plus 1 squared. That is x squared plus 2x plus 1. It is not x squared plus 1. That middle term 2x is the entire difference between the right answer and a wrong one. And here's why this trap is worse with circles than with parabolas. The circle equation already has a y squared in it, so you are guaranteed to square your substitution. Every single time. With a parabola, you might get away with it. With a circle, you never will. So write the parentheses first, then expand deliberately. Say it out loud if you have to. First squared plus twice the product plus last squared. Now, the geometry vocabulary. And it's just the discriminant wearing a hat. A line and a circle have exactly 3 possible relationships. The line can slice clean through the circle, entering and exiting, 2 intersection points. We call that a secant line, and it means D is positive. The line can just kiss the circle at a single point, that's tangent, and D equals 0. Or the line can pass by entirely outside, never touching. We call it external, and D is negative. Secant, tangent, external. 2, 1, 0. It is exactly the same trichotomy as the line and the parabola, because after substitution, it is exactly the same quadratic. New picture, same engine. Here's the shortcut, and it's genuinely elegant. You don't always have to substitute. Sometimes you can just measure. Think about it geometrically. Whether a line hits a circle depends on one thing only: how far the line is from the center, compared to the radius. If the distance is less than the radius, the line is inside reach, so it cuts through. Secant. If the distance is exactly the radius, it just touches. Tangent. If the distance is greater than the radius, it can't reach. External. And there's a formula for the distance from a point to a line. For the line ax plus by plus c equals 0, and the center h, k, the distance is the absolute value of ah plus bk plus c, divided by the square root of a squared plus b squared. Let's use it. Is 3x plus 4y equals 25 tangent to x squared plus y squared equals 25? The center is the origin, so the numerator is just the absolute value of negative 25, which is 25. The denominator is the root of 9 plus 16, which is 5. 25 over 5 is 5, and the radius is 5. Distance equals radius, so it's tangent. No substitution, no quadratic, no discriminant. Let's use that shortcut to derive a formula you'll see in your practice set. For what values of c is the line y equals mx plus c tangent to the circle x squared plus y squared equals r squared? Rewrite the line in standard form. mx minus y plus c equals 0. The center is the origin, so the distance is the absolute value of c over the square root of m squared plus 1. Tangency means that distance equals r, so the absolute value of c equals r times the square root of 1 plus m squared, which means c equals plus or minus r times the square root of 1 plus m squared. Two values, and that should feel familiar from session 5. Geometrically, it's obvious. For any given slope, there's a tangent line on one side of the circle and a parallel twin on the opposite side. A circle is symmetric, so tangent lines come in pairs. Let's do one from your practice set. The circle x squared plus y squared equals 25 meets the line y equals 4. What are the x coordinates? Substitute y equals 4. X squared plus 4 squared equals 25. So x squared plus 16 equals 25, which gives x squared equals 9. Therefore, x equals plus or minus 3. The answer is C. Now look at the wrong answers, because they're each a specific mistake. Plus or minus 4 just hands you back the y value from the problem. Plus or minus 5 is the radius. That would be the answer if the line were y equals 0. And plane 3 is the killer. It's right, but it's only half right. It drops the negative. That last one is the most chosen wrong answer on questions like this. Let's recap. A circle is x minus h squared plus y minus k squared equals r squared. Watch the sign flips on the center. And remember, the right side is r squared. A line and a circle form a nonlinear system, and substitution still works. Wrap your substitution in parentheses. With a circle, you always square it. The three cases are secant, tangent, and external, matching d positive, 0, and negative. Compare the center to line distance with the radius to skip the algebra entirely. For y equals mx plus c, tangent to a circle at the origin, c is plus or minus r times the square root of 1 plus m squared. And watch for Pythagorean triples. They're a signal the numbers are meant to be clean. Excellent work on session 7. Circles are no longer a special case for you. They're just another nonlinear equation that answers to substitution and the discriminant. In session 8, we raise the difficulty. What happens when both equations are nonlinear? You'll see systems with 4 solutions and learn the elimination tricks that make them easy.